In solving exponential and logarithmic equations, one-to-one property can be used. For example, if I said that 2 to the x is equal to 2 to the 5th, then x must equal 5. As long as the base is the same, the exponents have to be equal. So example, if 3 to the x plus 7 is equal to 81, the way this is set up, I cannot do the one-to-one property until they have the same base. So this one has a base of 3, this has a base of 81. I have to make them the same base. I know that 81 is the same as 3 to the 4th power, so I'm going to change that. I'm going to write 3 to the x plus 7 is equal to 3 to the 4th power. Now that these have the same base, I can set the exponents equal to each other. So I'd have x plus 7 is equal to 4. Subtract 7 from both sides, I have x is equal to negative 3. I would check that by putting the negative 3 back up in here for x. So I'd have 3 to the negative 3 plus 7, and I want to see if that equals 81. So I'd have 3 to the 4th, and 3 to the 4th does equal 81. So negative 3 works. Another example would be 25 to the 2x minus 3 power is equal to 1 over 125. The better you know your exponential values, the easier this is. I look at this and I can see 25 I can change to 5 squared. 125 is 5 to the 3rd power, but I need 1 over 125, so it's going to be 5 to the negative 3rd power. So I'm going to change the 25 to 5 squared. And I'm going to change 1 over 25 to 5 to the negative 3rd power. So I would have 5 to the 4x minus 6 is equal to 5 to the negative 3rd. Now that these are the same, I can set the exponents equal to each other. So I have 4x minus 6 is equal to negative 3. Add 6 to both sides, I get 4x is equal to a positive 3. Divide by 4, I have x is equal to 3/4. And once again, I would plug that back up into the equation to check to see if it works. One more example for exponential equations. If I had 8 to the x minus 2 is equal to 32 to the 3x plus 1 power, I need to make the 8 and the 32 the same thing. And I have to do it using exponents. I'm going to take the 8 and change it to 2 to the 3rd power. I'm going to change the 32 to 2 to the 5th power. When I raise to a power, I'm going to multiply, so I have to multiply 3 and the x minus 2. So I have 2 to the 3x minus 6 is equal to 5 times 3x plus 1 is going to be 15x plus 5. Now my base is the same, so I set the exponents equal to each other. So I have 3x minus 6 is equal to 15x plus 5. Now I have a basic equation to solve. I tend to like to keep my variables positive, so I'm going to subtract 3x from this side, subtract 3x from this side, I get a 12x. I'm going to subtract 5 from here to get 0, subtract 5 from here, I get negative 11. So negative 11 is equal to 12x. Divide by 12, I get x is equal to negative 11 over 12. And once again, I would check that to make sure that it worked. This also works with logarithmic equations. For example, if I had log base 4 of 2x minus 5 is equal to log base 4 of x plus 3. If this log had the same base, this log has the same base, these values 2x minus 5 must equal x plus 3. So I would set 2x minus 5 equal to x plus 3. Solve that for x. So I subtract x from this side, and this side gives me x. Add 5 from this side to that side, and I get 8. And these you do have to be more careful with checking. So if I had log base 4, 2 multiplied by 8 minus 5, that's going to be 16 minus 5, which will be 11. If I put a 5 in the other side, let's see if they're equal. Log base 4 of 5 plus 8 plus 3, sorry, 8 plus 3. 8 plus 3 is 11, so I have log base 4 of 11. They are both equal to each other, and the value of 11 is positive, so it works. If that value in this, after the logarithm were a negative number, that would be an extraneous solution, and it would not work. So x is equal to 8, works.